seems like it doesn't make any sense, but remember, we'll do the proof for this and stick with the fact that we proved it, that this thing actually works. And then just go with that blindly applying it everywhere. Okay, so that's the technique. Once we see the proof, we find out that, yeah, this is a true principle of induction, and therefore, it's okay to do it even if it intuitively doesn't make sense. S be a subset of N. Let S be N. This should have been all in blue. Okay, so let's do that.
Is the big N natural numbers or is it just a variable?
Yeah. Thank you.
Clarify.
The internet is really, it's important, otherwise I wouldn't have done that. Because the big N is gonna show up.
Yeah.
Well, this shows up.
Exactly. There's I've done too much bullshit in here, dude.
You know now.
Yeah, some shit's gonna happen or it's
You gotta expect the worst.
unnecessarily confusing.
It's true. If you do switch, it'll be very, very cool. So here is our set. So let S be a subset of N. And then that, so we can have everything on one page. One possesses the two properties. Okay. You can keep it like the way we're doing. Okay, and the true properties number one is this, that one belongs to S. And actually, it says the number one. Okay, so and it says it belongs to S, not to N, right? That's the N.
Yeah.
Supposedly. And I've been thinking about this in my illustration because this line doesn't mean that it's full of holes.
Yeah.
Only 1, 2, 3, 4 show up on this line.
Yeah.
But this line is full of gaps and holes and breaks, but it has direction, so it has order.
Yeah.
That's about the best thing we have.
Yeah.
That's why we're still using it, even though, you know. Okay, so number one, I mean, we see the number line used like this also in textbooks. So we have number one is in S, so let's put it here. And that's the natural number system. S, and let's just put it randomly here. Or should we just put it here?
Doesn't matter.
Well, what did I do? No, I did put it there. Why would I put it there?
Because it's an S.
And
Positive number.
what is the set of natural numbers?
Every number bigger than 1 or 0.
Yeah, and so this is the this is the first number, right?
Yeah.
So it should be
Okay.
right.
Yeah.
So if S is a subset of N, so it says that if S is a set of natural numbers and
Well,
S has one,
it doesn't have to.
I know.
We just said that this whole line is full of holes. That could be a hole.
This whole part. Yeah, I know.
Exactly.
I know. So in another proof, I put these things randomly. So let's go with what you're saying.
Okay.
Let's
I
see.
mean, I'm not saying you're wrong.
No. I'm saying that you have a point there because this line doesn't say it's the smallest number yet. Maybe the definition will say that. The definition does not say that. Okay. So this is considered to be the base case. And let me put here. I'm getting emotional. emotional.
Why?
I don't know. This was my favorite set. I'm going with this, even though you have a point. But I think the reason why we can put one here is that one is smaller than anything.
Yes.
But actually, I'm gonna put, let's just wait. I'm gonna go with you because I think you have a very good point. So we stick one in.
But either one works.
Yeah, this works. Let's do this. Okay, next, what's the second property? It says that if for every k, and I think this is when where one goes becomes an issue. For every k that belongs to the set of natural numbers.
That big or little k?
Big with a. Oh, this, sorry, this is a, I don't know how to do the small k. Is that no?
I mean, yeah,
Something like that, right?
yeah, it's just like an R, but I mean, you could just do that, just make
Yeah.
it small, that works.
Okay, so this is small. What this line is saying is, it's saying a couple of things. Number one, it's not saying for every k. You have to wait for the next thing, right? What it's saying is that every k that is a number here in the set of natural numbers.
Yes.
Okay, it's not saying that put k here or here yet. It says for every k that you can pick from here. And so that therefore wait for it. It says if k belongs to S. If we pick on random any k from here, and that k belongs to S. Now, one is already there. So we're not talking about one anymore. It's going to be anything larger than one. Okay. Then n k, so therefore k will be sitting here. To the right of one, and it can't be to the left of one.
Okay.
Because k has to be bigger. Because k is one of these numbers, not one. One is already there. So therefore, k will be bigger than one.
Yeah, because 0 is not a natural.
Yeah, and so therefore, what we're going to do is I'm going to move one here. So let's just put it here, so it's not crowded. And this kind of shows the true relationship. It's not just that the k is bigger than one. All k's are bigger than one. All k's are bigger than one. Okay, but you know, so or I'm going to put or here. This k or this k representing different numbers is bigger than one. Okay, so now if you have that situation, if k is in the set S, then the assertion is, and that will be proven in the, is that k plus 1 also belongs to S. So now let's draw this. So this was this, and on this one says you got 1. And let's say k was right here. It says k plus 1 will also be in S.
Yeah.
So what it's saying is that we need to extend.
S.
So we have to extend it. So let's see.
Why?
And that's the whole story. If, okay, so it starts with, is the number 1 in S? Yes. Is k in S?
Yes.
Yes. If that is, if this part is true, if you assume this part is true, then this is also true. And the proof will show us why. And if, so this is just the definition, right? The principle. So this is the definition. Definition says that if this is true, then this has to be true. So according to the definition, k plus 1 has to be here. Has to be in S, which means that we have to extend the K to the right. Okay, so in other words, as we find bigger and bigger Ks, the set S goes further and further to the right. If these two, because it says it possesses this condition, these two conditions are true. One is there, and if K is there, K plus 1 will always be part of that set. So initially, we chose the set S to be too small, because definition says that if K is in it, K plus 1 will be there. So we have to extend it. And as you pick bigger and bigger and bigger and bigger and bigger and bigger and bigger K, set S becomes bigger and bigger and bigger to the right.
Yeah.
So now if these two conditions are true, then this is the principal statement. So these are the two conditions. This is a very bad blue conditions. These are the two conditions. And now the principal statement shows up. The result of all this is, then we have S equals and so I'm gonna write here. So if we repeat or check for property 2 with larger and larger K, we find the subset S getting, now I'm going to say that word, B bigger and larger.